So when we're working with nonlinear functions, we can find what is called the average rate of change. And this is similar to a slope on a linear function. And on a linear function, we would have a constant rate of change. But with it being a nonlinear function, we're going to be calculating the average rate of change. Now, the average rate of change is between any 2 points on the graph. And we would draw a secant line, a line connecting those 2 points, and it would be a line, a secant line. And from that, we can calculate the average rate of change on that interval. And I'm going to do this a couple of ways. One, I'm going to do it graphically, and I'm going to do that first one graphically. But for right now, I'm just going to use this second equation or second function to just do it algebraically. And so let's say, for instance, that we've got this function, x to the fourth minus 6x squared plus 4x. We're trying to find the average rate of change between the points -5 and -3. So let's designate, and of course we know our slope formula, y2 minus y1 over x2 minus x1. And we're going to use these x values to calculate our y values and then calculate the average rate of change between the points where x is -5 and x is -3. And so let's designate this x, this -5 as x1 and the -3 as x2. All right, so I'm going to plug in, I'm going to substitute first -5 for x. So I'd have -5 to the fourth minus 6 -5 squared plus 4 times -5. So let's see, -5 to the fourth. Is 625. And then we've got -6 times -5 squared, or -5 squared is 25. And then positive 4 times -5 is -20. So we got 625 minus 6 times, -6 times 25 is -150 minus -20. So let's see what we got here. So 625 minus 150 minus 20. And so 455 is going to equal y1. Now let's substitute in -3 into the same function to determine y2. Let's say I'm going to go ahead and write y1. I mean our first coordinate up here. So when x is -5, y is 455. All right, cool. All right, let's substitute in -3 for x. Change colors on this. So now I've got -3 raised to the fourth power minus 6 times -3 squared plus 4 times -3. Let's see, -3 to the fourth power. Well, 3 squared is 9. -3 cubed is -27. -3 to the fourth power is going to be 81, I believe. And then we've got minus 6 times 9. -3 squared is 9. And then positive 4 times -3 is -12. And then we got 81. See, -6 times 9 is -54. -12. All right, 81 minus 54 minus 12 is 15. So our second coordinate, when x is negative 3, y is 15. Now let's put this into our slope formula and let's find the average rate of change. So I got y2, which is 15, minus $455, y1, over negative 3 is x2, minus negative 5. That's going to become a plus. So let's say 15 minus 455 is negative 440 over negative 3 plus 5 is 2. And negative 440 divided by 2 is negative 220. And that is going to be our average rate of change for this function, x to the 4th minus 6x squared plus 4x, on the interval negative 5, negative 3. Now, our top function, x cubed minus 2x squared minus 3x plus 2, I have graphed, and let's jump over here. So here I have it on the graph, and we're looking at the interval there when x is 2 and y is 3. And so let's see, when x is 2, y is right here. Let's say right there. No, can't draw it. X is 2, y is right here. And when x is 3, y is, I don't know, looks to be right about there. And we'll try to draw a line through here. So I could draw a line, well, that ain't very good. Draw a line through here, which would be our secant line, and we're trying to find that average rate of change. Now, I went ahead and printed out the table so that when x is 2, y is negative 4, and when x is 3, y is 2. And so my coordinates, then I could say that when x is 2, y is negative 4, and when x is 3, y is equal to 2. And then I can use that in my slope formula to find the average rate of change. So let's see, y2 is 2 minus negative 4 over x2 is 3 minus 2. And that's the negative negatives, make that a positive. So 2 plus 4 equals 6. 3 minus 2 is 1. And so my average rate of change is 6. So we did it algebraically in the first example. We graphed the second equation, which gave us this graph here of a cubic function. And then I went to the table, since we were dealing with integers 2 and 3 for x values, found out what y was, plugged that into the slope formula to find the average rate of change.